Hello friends, welcome to Module 4. So at this stage of the course, we're going to shift focus from growth and development to some of the more minute details of insect physiology. And that comes in the shape and form of their ability to sense the environment. Needless to say, this happens on the tiniest cellular level. But of course, the behavioral responses in response to stimuli in the environment happens at the macro level. So a quick overview of this module, followed by a very quick revision about how sensory systems work. We're going to dedicate 4.2 to mechanoreception, the ability of an insect to detect physical attributes of the environment. Then chemoreception, the ability of the insect to detect the chemical components of the environment, which is a really significant part in insect sensory systems. And as a subset of chemoreception, which is the basis of olfactory reception, so the ability to detect chemicals in the headspace around them and orientate towards specific cues or away from specific cues. And then finally, we look at vision and some of the complexities around the ability of an insect to see their world. Some things that they can see, some things they cannot see, and it's a lot easier to think about this relative to us as people. So just a very, very quick summary of the insect sort of basic sensory system. And I'll just get my laser pointer here. And I'm going to just start off with, there's a little bit of nomenclature here, right? But this isn't anything you haven't probably already done in first year biology. The dendrite is the sort of functional unit that is external to the animal. And in your case, it could be hair. In other animals, it could be fur. And of course, in the context of the insect, this is the CT. And there is a physical stimulation of the dendrite, which then creates what you would typically refer to as an action potential, which is a displacement of the electrical charge, which, because there is energy involved, allows the cell to be stimulated. So the cell that is basically stimulated runs along this sensory neuron here, which ends with a complex sort of structure called the axon. And it is the space between two adjacent axons where electrons can get transferred and so signals can get carried. So now we're from the external environment, we've undergone some kind of mechanostimulation, and there is a change in the charge, which then has a consequence internal to the organism. So in this little space here, in between two axons, we call that a synapse, where again, electrons can transfer. And there are some cells that are sort of, their only function is to relay the signal from one cell to another. We call them interneurons, you can see here. And then the activator cell, so the thing that actually creates a response, is this motor neuron here, which of course is maybe connected to a different tissue type or a different cell type with an expected response. And in this example, muscle. So you'd like to think that this is a dendrite that has the ability to undergo some stimulation, and the response that is a consequence of that is maybe muscular relaxation or contraction, leading to, at the macro level, movement of the animal.